So the Q1, if you think about a box plot, you have a 5-number summary. That summary consists of the minimum, the Q1, the median, the Q3, and the max. Okay, so when I reference, and this is page 11 again, folks, if I reference the Q1, I'm talking about the same Q1 that you would get from a box plot. All right. Same thing with the Q3, median, max, you know, like all that stuff. But the median and the min and max aren't relevant for this computation. Right? All I really need is the Q1 and the Q3. Now that IQR stands for interquartile range. That's Q3 minus Q1. All right. Fortunately, the NumWorks calculator will just give you the IQR. All right. So folks, we're in the note packet right now. We don't need the laptops for a few minutes. All right, so the laptops are going away. Phones, as always, go away. All right. So laptops going away. Laptops going away.
What is the S number?
Say it again, sorry.
What is the S number mean?
Oh, 5-number. That's 5-number summary. I have terrible handwriting. So the NumWorks is going to give you all of this information. It's just a matter of just popping it in. All right. Now we do have shortcuts. We actually talked about the shortcut for finding outliers, but it was a while ago, so it's forgiven if you don't remember it. But I'm going to just put the data into the calculator. I have some data in my V1. I need that for later, so I'm just going to move that over real quick. So what I'm about to do isn't relevant to us right now, but I'll show you how to do this at some point. Oh, wrong one. And one last minute. Okay. All right, so in value V1, I'm going to type in my numbers. 2, 4, 5, 6, 7, 8, 9, 10, and 42. Just double checking. Okay. My values are incorrectly. All you have to do is go over to stats. And right at the top of the list there, you see number of data points. I always look to that first, just to make sure I typed in the correct number of values. Sometimes, you know, that could be an indicator that maybe I made a mistake. All right, so it says I have 9 values in my list. I check, and there are 9 values there, so I think I'm good to go there. The minimum first quartile Q1 is 4.5, so I'd make a note of that. All right, my third quartile Q3 is 9.5, and my IQR, you go down the line a little bit, up, not over, but down. IQR is 5. All right. You probably don't need the technology to tell you that, because if you know IQR is equal to Q3 minus Q1, you get it pretty much immediately. But it's nice to have it. You know, it's one less thing to worry about. All right. So looking at this formula, I mean, it's an intimidating looking formula, but it's really not bad, because all I'm doing is replacing the Q1 with a 4.5, the IQR with a 5, right? That happens twice, and the Q3 I'm replacing with a 9.5. So I would write this as 4.5 minus 1.5 times 5, and then 9.5 plus 1.5 times 5. All right, so again, I'll just do a color coding here. It's really just a little plug and chug action. All right, so if I do the computation, I mean, you could do it on the calculator, or you could do it by hand. It's up to you. Thank you. But if you do it in the calculator, you go out to the home screen, go to calculation, and then just type in 4.5 minus, basically what you see, 1.5 times 5. Don't bother with the comma. Just do the left part as one computation and the right part as another computation. All right? So you get a -3. And if I do 9.5 plus 1.5 times 5, I get a 17. This is my interval of non-outliers. All right, interval of non-outliers. So if you're looking at a data set and you want to determine if there are any outliers, you would basically just you define any value that doesn't fall within this interval. All right, any number that is not between -3 and 17 is going to be an outlier. So I would just go through and ask myself, is the number I'm looking at between -3 and 17? So I look at the 2, that's definitely between, if you're looking at a number line, I'll just do a quick one up here. You got -3, I'll put 0 over here, and 17 somewhere way out here. I'm looking for any number that falls outside of this interval. All right, so these are non-outliers. All right, so anything out over here would be an outlier. All right, 2 falls between -3 and 17, so does 4, 5, 6, 7, 8, 9, and 10. The one number that doesn't would be the 42. You got it. All right, so 42 is an outlier. Sometimes you can determine outliers just by context. I didn't give you any context here. I just gave you a list of numbers. But if I told you that these are the ages of school-aged kids, all right. I mean, the 2, you'd look at that and say, okay, well, I think 2 is probably a little bit too young to be somebody in school. 42, school age, you're talking about like elementary, middle, and high school, right? I suppose you could be a college student at 42. I mean, I know you could be a college student at 42. I have plenty of them in my night class. But, you just really never know, right? But the context could be a determining factor. So if I said, for example, that these are the ages of elementary school students, then I would say, okay, well, the 2, the 4 really shouldn't be there. 4, I guess you can make a case for, but 2 and 4 really shouldn't be there. And then, well, 10 puts you in 5th grade, I think, so that's fine. So the 2, the 4, and the 42 would most likely be out. All right, that's just using the sense based off of the context. All right, but if you don't have context, or the context is it has a lot of gray area, then the numbers, the computation would be the way to go. All right, so I'll show you how to do this on Excel in a couple minutes. The data set for unusual values, the data set that you're given will have a mean and a standard deviation. All right, whether it's the raw list of values, 2, 4, 5, and so on, you can always compute a mean and standard deviation. All right, so when you see a request or a question that's asking you to find any unusual values, you're going to follow this computation, x bar plus or minus 2s. All right, so x bar plus or minus 2s. All right, you could ignore the one with the Greek letters, the mu plus or minus 2 sigma, because that's only for populations. We'll get to that in the second unit. All right, but for now, I'm working with this computation. I'm pretty much doing the same thing that I did for outliers, just different substituted values. All right, so this expands to x bar minus 2s, comma x bar plus 2s. All right, this is the interval of usual values. Yeah, let's go ahead and kill that music, please. So I'm given a mean of X bar and a standard deviation of 4. Oh, well, the mean X bar is 72. Standard deviation S is 4. So they give me those numbers. All I got to do is pop them in my expression here. X bar gets replaced with a 72 in both cases. And the S's get replaced with 4s. All right, so computationally, it's not that bad. I'm going to do 72 minus 2 times 2s is 2 times s, so 2 times 4. And then I'm going to do 72 plus 2 times 4. All right, one of the reasons why we do so much stuff on Excel, Google Sheets, is because we set it up the one time and then you could replace the data and use it over and over again. Right, so you don't always have to run the numbers. Right, but this is really saying 72 minus 8, 72 plus 8, so 64 to 80. All right, these are the usual values. So when they ask me, is 59 unusual? If it's in this interval, this is the usual interval. You know, it's a set of usual suspects. Usual interval. Interval? No, interval. All right. So we would say that 59 is unusual. All right. A really simple way of thinking about the difference between unusual and an outlier is outliers are just extremely unusual values. All right. So they're unusually unusual. All right. So it's kind of another level of unusualness. All right. In terms of practical conversation, daily basis kind of stuff, if something happened that you looked at it and said, oh, that was kind of weird, I didn't expect that to happen, that's unusual. If something happens that you look at it and say, that's impossible, you're lying to me, that's an outlier. All right. So if it starts raining outside, right, and it's in the middle of a drought, that's unusual. Right? It can rain if it's in the middle of a drought. Yeah, it technically can rain. You're just not expecting it to happen. All right. But if you're in the middle of a rain, if somebody comes in from outside and they're in the middle of a rainstorm and you don't see an umbrella, no poncho, nothing like that, but they come in from the rainstorm and they're completely dry, and they say, I was standing out in the middle of the rain for 10 minutes, you'd look at that and say, well, that didn't happen. All right? You don't meet any of the criteria for that to actually have happened. So that would be an outlier. All right? So you just think of extremely unusual, outlier, shouldn't have happened. All right? I flip a coin and I flip a coin 1,000 times and somebody tells me that every single one of those outcomes was heads. That didn't happen, right? Unless it was an unfair coin, you know, double-sided, both sides have heads on it. Like, that's the only way that would have happened. That's an outlier, all right? But if you flip a coin 10 times and 8 of them are heads, I could see it happening. I didn't expect that to happen. I would say that's probably unusual, all right? Now I have a set of raw data here, but we're going to skip that. We'll go right to the outliers and unusual values. I just got to put the link on Schoology because for whatever reason I never remember to do that. So let me